Hello, everyone. This is Sherry Greenhouse, Managing Partner of Serum Exchange, and I'd like to welcome you to today's session where we are going to discuss building great what-if models and the resulting analysis for your CEO. So what I am going to do now is introduce your presenters. We have Adam Settle, Vice President of Product for Sharpen Technologies, and Adam is an experienced educational professional skilled in sales, coaching, team building, and training, and he's a very strong facilitator, combining his study of education with his experience from his time as a trainer in Apple and Angie's List. So that's Adam. And first, you're going to hear from my buddy, Rick Kasiba, Chief Data Scientist for Sharpen Technologies. And Rick, this is probably year 12, maybe, that we've been doing
I had written down
webcasts.
I had written down something like year 16 or 17.
Oh, okay. So one of our first set of webcasts, Rick did. Rick at Sharpen, Rick is Chief Data Scientist. He's responsible for developing data-driven initiatives to optimize the agent performance and to use Sharpen's reporting tools and data layer to enhance the customer and agent experience. And when Rick and I first started working together, he was a co-founder of Baybridge Decision Technologies, where he developed the contact center industry's first what-if decision engine. And he has a PhD in operations from Purdue. He's amazingly smart. Not that Adam isn't, it's just that I know Rick for much longer. Amazingly smart. And there's so much he's going to go over with you today. So I am going to turn this right over to Rick.
Well, thank you so much. And before we get started, I want to thank the awesome Sherry Greenhouse for all her help on this webinar series. I actually did try to go back. And Sherry, when did you start CRM Exchange?
End of 95.
Okay, all right. So it was probably like 2002, 2003 when we did our first set of these. But just been an absolute joy to work with. I also want to thank Zoe Chen. Zoe is a new analyst at Sharpen. She actually spent the weekend going back and forth over some of these algorithms that I'm going to show you here. She's really smart and a joy to work with. And a lot of the ideas that are in this deck are actually her ideas. So I'm actually plagiarizing a little bit. And I want to thank you all for taking time to chat about contact center what-if models. I hope it's fun. We, I think, are a rare group who enjoy this kind of stuff. So why don't we go ahead and get started here. Okay, so today we're going to chat about contact center modeling and its benefits. We're going to talk about ways to fiddle with the models to make them a little bit more accurate. And then we're going to solve a couple problems using these models. So let's talk about models first. Okay, so math models, when you think about contact centers, math models are so important in that the modern contact center is really managed by math models. If you think about it, math models are at the core of workforce management. They're at the core of call transcription and AI. They're at the core of forecasting. They're used for scheduling, staff planning, longer-term planning, budgeting, what happened analysis, and what if analysis. They really are, they're how we manage the modern contact center, and it's really good to know how they work. And we're going to talk about a branch of them and how those are developed and how they work. So in general, a math model is basically a mathematical representation between inputs and outputs. And inputs can be a forecast, inputs can be actual history, outputs are usually performance metrics. So they're things like my service levels and my speed of answer and my abandons and my occupancy, but you can even extend them to things like your costs and your revenue. So the models that we're going to talk about today really are, at its most basic, is three inputs: volume, handle time, staffing, and out of them come your service levels and your abandons and your occupancy, and then again, by extension, cost and revenue. We're also, one of the inputs that we're going to sort of glaze over is also the expected customer patience. We're going to talk a little bit about that. So let me go over here. let's talk about the level of detail on models. Oh, wow, these bullets are huge. So the trick is that models need to be calibrated for the business questions being asked. So, for example, short-term models are really talking about things that have changed today, things that are changing today in my environment. How do we respond to those changes? For example, volumes are coming in higher than we expected, or too many people have called in sick, or our handle times are changing, or people are calling us for a different reason today because something changed in our environment. So you would build a short-term model to help you with those things. Now, you wouldn't use that same short-term model for the next type of model, which I'm going to say sort of mid-length or daily models. So a midterm model is something has happened that will change our week. We've noticed that there's something in the news, and a funny one is I remember I was at a credit card company, and Oprah, on an Oprah show, they said something about that particular credit card company, and they got hammered for the rest of the week. But something changes in your environment, and so it allows us to make some, we need to make some changes around our environment for the rest of the week or for the next 10 days or so. So these things are too near to hire for, so we got to be making decisions around, should I offer overtime tomorrow, or maybe should I send some people home early next week, or all these things that are changing, and the types of decisions are midterm. And so you'd build a daily model for something like that. And then your longer term models are things like, how do I put together a budget? When and where should I hire? We're coming out of COVID, so what's going to happen for the next 6 months? And how do we position our company for that? And we would want to do a lot of sort of medium-term to longer-term what-ifs. So how do I organize my work? How do I, do we offer chats, or which channels do we offer? Those kinds of things would be solved by a longer-term model. And again, the trick is we will build different models based upon the types of business decisions we're trying to make. Now let's talk about there we go. That's exactly what I just said. So there we go. Adam, you're laughing at me.
I was muted though, so it didn't count.
Okay, it didn't count. All right, good. Okay, so there's a whole bunch of different modeling techniques. And the type of model that we're talking about here is basically a contact center simulation model. So again, I'm going to make a change to my volumes. What happens to my service levels, that kind of thing. And there's, like I said, there's a bunch of techniques, but when we're building a contact center model, there really are just a few that are sort of prevalent today. The first is something, I call them in math lingo, sometimes they're called a continuous model or queuing model. In our contact center space, we typically call them an Erlang A, C. I've seen an Erlang X out there, but the Erlang family of models. But they're queuing models. Now, the good news about them is they're very fast. You can just crank through, if you're in terms of computational speed, they're really quick. They're easy to find. You can download some of these to your spreadsheets. They're very well understood, and it requires little or really they require no data. The cons are that they're not always accurate. They oftentimes need to be kludged to calculate complex environments like a multi-channel environment. So continuous models are most prevalently used primarily because they're fast and easy, and people have a lot of experience with it. The one that I've been talking about for years is something called discrete event simulation modeling. The pros to this is they're extremely flexible. They're extremely accurate if you set them up and calibrate them, and they're fantastic for what-ifs. The negative to them is that they can be very slow, and they require a lot of expertise to build them. So you might have to require an industrial engineer or some sort of simulation builder to build them. But the thing is, if you want to, they are really fun. And if you want to get into it, by all means you can, because it's not that hard, but generally people shy away from it because they look hard, but they're not. The software is still expensive. If you wanted to buy some general purpose simulation modeling software, it's pretty expensive. I want to tell you a secret. This is something that I've never, ever talked about before. Back in the day, I was talking about how you can use discrete event simulation modeling to be fast. And let me tell you how we did it way back in the day. It's not being used now, but it's the way we used to do it. So we would build these simulation models for people to do long-term plans. And they were so slow that you couldn't do them real time. So what we would do is we would actually run them hundreds of thousands and millions of times using a room full of PCs that we're just cranking through these simulation models, and we store the results of them into a database and deliver that with our software. So that was a way that in the olden days, people would try to speed up discrete event simulation modeling. And it's still slow relative to the queuing models. And then now everyone's starting to talk about AI models. And there's a lot of software tools out there. They're cranking out an awful lot of people who data scientists, so a lot of college grads are going into this. Software has actually become cheap to the point of almost being free. And they're great for solving very specific types of problems. The con is that they only solve a subset of the problems. They're really easy to misapply, to actually solve the wrong problem with. People it's almost like what's the old thing? You've got a hammer and a nail. If you got a hammer, everything looks like a nail. If you have an AI background, everything looks like an AI problem, and they're not all those kinds of problems. Expertise has become expensive, so the AI kids who are coming out of college right now are actually pretty expensive. And here's probably the biggest problem with it is it requires an awful lot of data and an awful lot of clean data. So projects can get frighteningly expensive. I've seen projects that that started off as a beta. This isn't at Sharpen. That started off as a beta, turned into a two-year beta with an awful lot of expense on the customer side. So there are some, these are the types of models. These are sort of the pros and the cons. I'm going to talk about that first batch, which is your Erlang. Now this, I started looking at my slides this morning again, and I figured out this morning, which was too late because I had already sent Sherry the slides, that this is actually a really, really terrible slide because, and Adam sort of hinted at it to me, he was very nice, but there's just too much going on in this particular slide. So I'm going to try to walk you through it. So let me just look down here. On the x-axis over here, we have date, okay? And on the y-axis, we have time. We're keeping track of average speed of answer. And I'm a little colorblind, but this line here, I think it's the reddish line here, represents what actually happened in a contact center. So this is their history. This is the average speed of answer that they achieved over the last 4 months. Okay, so that's what we're looking at. And if I were designing this slide again, all the other lines wouldn't be here, and then I'd sort of bring them in. What we have in the other lines, though, is an Erlang A model applied to it. Now, an Erlang A requires basically 4 inputs: your volume, your handle time, and your staffing. And we can get that from history. So what I've done is I've taken those 3 inputs and I've taken what actually happened on this particular day in terms of the amount of staff they had, the handle time that they had, and the volume that they had. And then what we're changing is the 4th item, which is the customer patience. Now, we have a rough idea of what the actual customer patience was. We can actually look at the data and get that. But what we're doing here, this is back to Zoe doing a good job on this work. What Zoe did was she was looking at varying the customer patience part of the Erlang A equation. And so this line right here is an Erlang, let me look here, Erlang A equation with a 0.6 minute average patience for the customer. And then this next one is an average speed of answer at an Erlang A with a 1.2 minute patience. This one has 2 minute, one of these has a 2 minute patience, and then, 2 minute patience, and then the average speed of answer here. And so you can see you can actually run this multiple times. The Erlang A is fast enough to go ahead and run. And developing this chart probably required her to do some coding or something at the beginning, but she was able to crank these out actually pretty quick. So we can run one with 0.6 and 0.7 and 0.8 and 0.9. So we can run a whole bunch of them if you want to see which one is most accurate. Let's see what else I had in my notes. So that's it. The trick is that we can actually generate not only 3 of these things, but we could generate hundreds of them. And that's actually what Zoe did this weekend. So let me go to the next slide here. So here's one way that you can, so the question is which model should we use? Okay, now this little orange one is close. It has an average error of 0.8, 8.6%. I wouldn't say that that's particularly good. The blue one here is minus 44% on average, and the yellowish one is 76% off. Another way to look at this is what we're plotting here is the actual ASA. So every one of these data points is an actual ASA and then the predicted ASA for that data point. So this particular point right here, they actually achieved a 22-second ASA, but the model was predicting a 15 seconds. So that's the error that you can see. And if we had a perfect model, it would have been a 45-degree line here. If it was right along that line, you say you have a perfect model. Let's ignore this one over here to the right. We're not even looking at that one. So I got to click another button here. So the question is, are these good models? Well, statistically, this looks okay. It looks okay. But here's the problem, which is for those of you who are of a statistical bent, here's something that I've noticed in my many years here in call center math, is that the standard tests aren't necessarily great for us. So, for example, there are things that you can do to you can look at the mean absolute error. You can, what are some of them? Mean absolute error, average error, root square mean error, and all these sorts of things. And they're all designed to help you look at generic data and sort of figure out whether they're good. But the problem with this is for a call center or any other kind of business that you're building a model for, you want to look at how you're going to use the model in decision making. So here's a great example. I've used this before. If I were building a staffing model, so a long-term model, and this is week over week out into the future, maybe a year or so, and I want to look at seasons and hiring and budgeting and all that sort of stuff, the thing that makes the model good or not isn't necessarily how each data point, how tight each data point is. What does matter is how tight they are at my peaks and maybe my valleys. So because if I'm putting together a budget, the thing that I would like to do is I would like to have, in effect, the right amount of money for the year. How it gets allocated over the course of the year isn't as important as that I set the right budget number, and that I have enough staff hired so that they manage my peak, or I am able to get people off the phones enough to manage my valley. So what matters isn't necessarily each data point, but what matters are my peak data points. And so I might have 10 data points that are more important to get exactly right. Or maybe I never want to overstaff, so I'd rather there be a bias in the negative direction. So these kinds of standard techniques for finding goodness of fit and figuring out whether a model or a forecast is right isn't necessarily what you want to do. You want to be able to understand the limits on your business problem, what you're trying to solve, and the implications to actually doing everything wrong. So if I get it wrong, which way do I want it to be wrong? That kind of stuff. So anyway, I think that's just an important point. It's something that I always tell my analysts because I think it's really important. And the problem that we have, of course, is that the real world isn't clean. Erlang and simulation models, and AI for that matter, they all assume certain sorts of behavior. So, for example, an Erlang model, and I know I'm going to get the wrong one, it has an exponential distribution associated with, this is for Erlang A, exponential distribution associated with the patients. So that distribution may not be right for your business. A simulation, you can build your own distributions, which makes it nice. But there's going to be some assumptions like our data doesn't show that the agent actually gets off the phone to handle an email real quick. Even though, because it's on a different system or something, even though I'm logged in and everything, I'm actually doing something else, and the data doesn't show it. Or maybe there's some anomalies in our data, like agents not logging out or calls getting stuck. Or a fun one that I always love is, as you're talking to a call center person, the manager of the call center infrastructure, the IT person, will say, yeah, we started getting really busy, so I started playing with the call routing at that point because I didn't want us to be so busy. Well, then it means your data isn't right, and which means the next time you do staffing for that call center, you're going to assume that guy's going to be there to fool around with their routing, and you won't staff appropriately by queue. So things like that will mess up your data. And also, throughout the day, you're actually getting different people are calling for different reasons. A very small customer of mine years ago had different service standards by time of day because people were calling them for different purposes. They were a hotel chain, and they knew that during the work hour, people were calling for business purposes, and in the evenings, they tended to call a little bit more for leisure travel, and they had different patients by time of day. But those differences will throw off your model, okay? So all of these things are reasons why models aren't perfect. There's a type of model that I've never really talked about before, but I think it's really cool. It's called an ensemble. Basically, what you do is you take a bunch of candidate models and then you average them together. So an ensemble model is simply a linear combination of different types of models to make a better performing overall model. In effect, what we're doing is, click here, is we're taking this model here and then we're going to average them out in some way. So we're going to take a weighted average. So I might note that my orange line is the best, but it tends to be understaffed a little bit. So I might average it with the one that's overstaffed and weight this like 0.1 and weight this 0.9, and I'll come up with a better overall model. And there's nothing in the rules saying that you can't do this. A lot of people will say, oh, you got to watch out for this and that, but all models are just representations of averages of this, and I'm assuming a distribution of that and all that sort of stuff. So averaging models is completely copacetic, and it actually makes an awful lot of sense. Let me show you why. So what it is it's exactly what I said, a linear combination, A times model 1 plus B times model 2 and C times model 3. A, B, C are constants, and they tend to average to 1, or you can add them up, and they add up to 1. And this becomes your new ensemble model. And I think I wrote a note down here because Adam asked me a question. So let me look at my notes here. No, I didn't write a note here at all. But the idea is that there is software out here that can help you with all of this sort of stuff. That was your question, right, Adam? You can build a regression model to come up with your A, B's, and C's. That's pretty easy. That's what Zoe was doing. But even you could even just sort of do a guess and test, and that would probably be better than just using one of the models as opposed to an ensemble of them. Let me show you some of the results that we got by doing it. So in effect, what we're able to do on that very same model, this is the same data, it may be a slightly different range. Using an ensemble model, Zoe was able to come up with an average error of minus 1.9%. In terms of a daily model, this is extraordinarily good. Now, there are some days where where we just completely blew it. This day here, we predicted something low, and what in fact happened was something very high. But these are real world sort of events. It may mean that something changed in the environment, more people were not adhering to their schedule, or something was changing in the environment that day, and it screwed things up. But that's normal. That's normal. I always love to tell the example of if you have a small center, and let's say I have 12 people who are on the phone right now. Adam and I are, on the phone, and we sit down at our cubicle in the days that there were cubicles, and we turned to each other and said, hey, did you see the football game last night? Yeah, can you believe this? And we start talking, and we have a 4-minute conversation, and for that 4 minutes, we just knocked out 20% of the workforce. And that will screw up any kind of model, because no model is going to be able to predict sort of the randomness within a time interval. So anyway, kind of cool. So what's neat about this, of course, is that we have these optimal weights, and we do a pretty good job. Now, I also think that she didn't build an ensemble from 3 Erlang A's, but she built an ensemble from 40 or 50 of them, which is kind of neat. Here I'm doing the same thing, but we're doing it by week. Remember, it's if our decisions are longer term, we'll want a model that mimics the longer term better. So we're doing exactly the same thing. We're building an Erlang A model. We've done 3 of them. This is over by week. So we're taking that same history, but looking at it by week. We see we have with this blue model a minus 23%, minus 5%, 13%. And again, this is Erlang A with a 0.8%, 0.8 minute patience. This one has a 1.2 minute patience over the course of the week. So that's neat. But here's what happens when you actually combine them into one model, and we get a model that's only minus 1.5% off. There are things that I would do to try to tweak this a little bit more, and we'll talk about that here in a second. But this is a really, really good swag. And that means that if I'm making a long-term plan based upon a forecast that I build, this is going to be at most off, probably 1 or 2% off in terms of making my longer-term decision. My hiring decision will be within a couple FTE, which is where you want to be. So that's really cool. Okay, and remember, if you have any questions, please type them all in. And I hope this is interesting to you guys. All right, so here's what I would do with it next. And this is what, if you're in the game of tweaking computer models, here's what you might want to do. You might want to start with, to build a good ensemble model, you start with an Erlang C, and then you add an Erlang A with 30 seconds, then an Erlang A with 5 minutes patience. And so I, run 50 Erlang A's with an Erlang C. And then I might add a couple fudge functions. So I might add a, +2 or +3 seconds or whatever, just a little fudge factor in there. And then what I do is I build I build with these functions, I build an ensemble and let my model, if you're using some sort of regression model in here, you have the model pick the weighting on these and you see how good it is. But then I might want to do something, which is by day of week, have a different model. So that's over here. So by day of week, because for example, on weekends, people are calling you for different reasons than they are often calling you during the week. You might find that you have a 1st and 15th problem if you're a financial services company where people get paid on the 1st and 15th. So the reason why people call you on the 1st and the 15th are different. So I might have a different model for the 1st and the 15th. And I have seen people do this. I have seen people build a different ensemble by hour of day. That seems a little bit much, a little bit like overkill. But if you've got an awful lot of data, maybe it makes sense for you to go ahead and do it. And I bet you would come up with some really, really good results. Now, the way you build these models, so let's say I want to build a different model by day of week. Let's say I want to build a Tuesday model. All I do is get rid of the rest of the days of the week as my data set, and then I can build a model just on Tuesday. And then when Tuesday rolls around in my modeling exercise, I use that specific model for my Tuesday. Super easy to do. Another one, and I've never done this, but I think this is probably pretty realistic, and I will start experimenting with this in our modeling process here at Sharpen, is to build a different ensemble for when occupancy is high, high versus when occupancy is predicted to be low, because I would expect that agents behave differently, and certainly customers might behave differently when they're on their phone for a long time versus a short time. And the idea is to go through all of these steps, and I know there's some more great ideas for coming up with a better model, is to show the benefit of all of them at each step. Maybe you'll improve things, maybe you'll make things worse. But just go through this guess and test sort of thing where I'm changing things and playing with this and have a morning model versus an evening model or whatever it is that I'm doing. You can get really, really tight models, and you don't need to be investing in expensive simulation technologies or buying yourself some data scientists or things like this. This is actually relatively easy. All right, let's see here. So once we're done with tweaking and playing with this thing, and you know that it's really accurate, what we want to do is we want to take these models out for a spin and do some analytics, and we're going to talk about that here in a second. So we're starting with a real scenario. And at this point, I'm having a drink of my tea and handing it off to my buddy Adam Fettel.
Well-earned.
I've been rambling, dude. I've been rambling.
You haven't been rambling. This has been wonderful. I've been watching the Q&A, and I think you've done a good job of touching on some of these pieces. And just to kind of recap, there was a few slides ago that I think really lays it out well. Of you don't have to invest necessarily in AI. You don't have to invest in a bunch of data scientists. I think it's really cool to think about how you can get better data based on what you have. And so, with that, we're going to kind of pivot into what a couple real world examples look like. And Sherry alluded to, this is the last webinar in our series. I'm going to try and tie a few of these webinars together. She talked about agent performance. So we're going to start there. A few webinars ago, we said it was really important to make sure that you were showing your agents the metrics that matter the most to them, showing them their goals. How do they stack up against their peers? Agents want to know that they're doing a good job. And especially if they're doing well, they want other people to know it too. And that includes managers. So that's where we're starting here. The few examples we're going to look at are these agent controllable metrics, just to tie these themes together. And so one way to do that, we said, was to just think about that oceanfront real estate that you have, the screens that your agents are looking at, and how do you surface those metrics there? This is an example of how we do it, but our key takeaway was make sure that you're showing agents often how they're doing, what their goals are, tying back to the way that they're stacking up against their peers. And on the next slide, we can see what that looks like. You know, the outcome of this as we bring this back to data is that they respond pretty quickly to it, which is great. So this is an example of first contact resolution over a 3-day period. And you can see that red line is when we started showing agents that first, thank you for that, Rick, I love that little pointer. We started showing agents the data by just putting it in front of them. And so, you know, I think the sound bites in here are great where you say, you know, we have people pushing 80, 85% first contact resolution when initially they thought anything above 80 was aspirational. And then on the flip side, you have agents saying, I can't believe I'm 8th in first contact resolution. I'm going to do better, right? They have that natural tendency to want to do better. But when we think about it, we go, wow, check this out. We've got a 5% increase in first contact resolution. And that begs the question, well, what's the benefit of increasing first contact resolution? We all inherently know that, right? And Rick, I love that you picked this picture because this is the doppelganger of someone that I know. And maybe it's the actual guy I know, but every time I see the picture, I'm like, hey, I know him. His name's Brian. It's probably not though. But we think about that from what does it mean to improve first contact resolution, right? We say, if we have a better experience, we drive, you know, a better experience for the customer. We know that a better experience from an agent also drives the better experience for the customer. So it's cyclical, right? It all feeds on itself. And we say, well, if agents are having a better experience, and they'll lead to better CSAT scores, it may increase average handle time, right? To solve a problem completely might cause other metrics to flex a little bit. In this particular case, that didn't happen, but some metrics, especially quality metrics, could cause efficiency metrics to look a little bit worse. It also means that we have a direct reduction in our call volume, right? If people aren't calling back so frequently, then we have that extra time by having less call volume. And so by putting these metrics in front of agents, we see all of this. That helps us key in on outliers to focus on, well, what are the right behaviors to drive first call resolution. But then now we're going to try and tie the model together so that we can take what Rick has been talking about and say, hey, this is an agent controllable metric. We're starting to positively influence it. How do we look at the data and the modeling to say, well, what's the actual benefit of that? We all inherently know that it's good to make first call resolution better. But how do we prove that with data? And that's what I'm excited to kind of bridge the gap here as we head into the next slide. I hope your tea was excellent.
So let's look at this. So what we have here is on the x-axis, we're keeping track of volume. So and on the y-axis, we're looking at average speed of answer. Now, what is this line? This is that model that we just built. So I want to say this is a daily model. But what we have done is we have our ensemble model. We're holding everything constant. We're taking that day, putting in their metrics. So we have the handle time, the staffing. We're changing volume, and we're keeping track what happens as we add more volume or take more volume away. You see, you get the shape of this curve associated with that. So this is what your ensemble model is telling you is going to happen. And because you validated, you proved it over time that it's actually accurate on history, you can assume that the what if is pretty good too. So let me show you a couple things here. So what we said is that we got a 5% reduction in first contact resolution. That should lead to about a 5% reduction in overall volume. So if 5% of my calls usually call us back, but now they don't, you would expect at least a 5% reduction in volume. So what does that do for you? What you can do is you can go to this right here, this point is where we were historically. So this is where we started from. We're going to reduce our volumes by 5%. And you can see that this would result in a 3-second change in average speed of answer. So the question is that worth much? 3 seconds doesn't sound like a whole heck of a lot, right? And at this particular point, we have a choice. And the choice is I can just have a lower ASA. That's cool, right? Or I can go back to the ASA I had before, but with fewer people. And so a 5%, that's what I just said. So here we go. All right, so what we have here is that this 3-second ASA, as I look at staffing versus ASA, so this time I'm taking the same concept, I'm holding everything constant, I'm holding the volumes constant now, and I'm holding the handle time constant, but I'm changing my staffing. So what I can do is I can say, what does a 3-second ASA improvement buy me? Well, it saves me approximately 5 FTE savings at this particular call center that has about 120 people in it. So what does that mean? Well, it means that I can save $225,000 a year, or I can put that $225,000 back into my contact center by keeping the staffing where it is, and I'll just run a slightly better average speed of answer, which is cool. So that is how we quantify. It's one of the ways you can use models to quantify some sort of benefit that you might or might not be getting, or might be getting, or want to evaluate. Sometimes vendors will come in and they'll say, "Hey, we've got this new technology. It's going to save you 20 seconds." You say, "Okay, well, I expect maybe it'll save me 5 seconds. So let me go ahead, look at my model, and see what that would mean in terms of dollars." You can use this for ROI analysis as well. All right, let's do another one. This one is, and this is another one of those performance management results that we got from our previous webinars. This particular company saw an improvement in handle time by, I don't know what this percentage is, it's probably about 7 or 8%, but it is, whatever that is, 1.6 minutes in handle time. These are long calls. So we can do the same exact thing here. Here we have on the x-axis handle time, and the y-axis, it's average speed of answer. So we saw a 1.6-minute reduction in handle time. Well, surprisingly, I thought this was going to be a lot more, but it was 4 seconds in terms of average speed of answer, right? So again, saying going from here to here yields a 4-second change in handle time. And all we're doing is we're using our model. This is that Ensemble model again. But again, we're holding something constant, varying other things constant. I don't know if I said this, but this is called sensitivity analysis. It's a really nice technique. It makes it really crystal clear, especially when you're talking to your executives, your CEOs, and your COOs, and you're saying, let's walk you through how we did something. It's a really nice way of showing people these changes. So we see a 4-second change in average speed of answer. Let's figure out what that means in terms of staffing. So same sort of thing, actually, it's the same exact curve, because I'm using the same exact model. A 4-second ASA yields you a 9 FTEs of savings, which means, of course, that is going to be pretty expensive, $468,000 per year, or you can reinvest it and get a better ASA, or you can go somewhere in between, and you can do that just simply by drawing a graph from here to here and saying, putting it in the middle. So you can use these curves, again, to show people what their alternative decisions are. Oftentimes, modelers think of themselves as people who are, I'm building a forecast, or I'm building a model of the call center operation. But really, that's not what the people who are doing this sort of stuff really are doing. What they're doing is about laying out alternatives for decision makers. There's a branch of math called decision science or operations research, but it really is about how do you use math, things like this, and models to come up with better business decisions. And this is one of those ones. Say, okay, decision maker, here are your options. All right. Here's a business question number 3. And I've seen this happen. I've actually been around when a company was doing this sort of thing. The consultants want to reduce our ASA goal. We're a hot premium brand company. They want to reduce our ASA goal from 35 seconds to 25 seconds. The question is it worth our while? All right, so here's what they want to do. They want to go from 35 seconds down to 25 seconds, which means that it's going to go from that to this is going to means that you need to hire an additional 26 FTEs. Again, this is one of those things where I didn't expect the number to be as big, but it is. Depends on where on this curve you are and the shape of this curve. But they're going to increase things by 26 FTEs in order to do this. The question is, what are the other implications? Well, one thing is, here we're plotting staffing against occupancy. So again, we're holding everything constant, only changing staffing and keeping track of occupancy as your staffing increases. It means that you can expect, and you should tell finance this because they're going to not like this occupancy number, is that you're going to go from an 85% occupancy down to a 65% occupancy in order to hit your new ASA, which is much higher. So we're a premium brand, great. We're going to get high ASAs, and our agents are going to be less busy by 20% of their time. So that's what I said. Okay, and then we're going to see what happens to our abandonment rate. So we add that 26 people. We go from, so here we're staffing against abandonment rate, and we see what the repercussion is. We're going to go from here to here in terms of abandon, and it's going to reduce our abandons by, actually I did it the wrong way, from here to here. It's going to reduce our abandons by 1.1%, which is really cool. So we're going to get fewer abandons. Now, here's where it gets fun. So when you're talking to the consultant, you can whip out this table and say, look who's really smart here. And it's this one here. So we're going to go from 35 seconds down to 25 seconds. Well, what changes? Well, our abandon goes from 7.4 to 6.3%, which means we're going to have 1.1% fewer. Our staffing is going to go from 111 to 147, which means we're going to have 26 extra people. Our occupancy is going to go from 84 to 65, meaning people are going to be more idle, which is okay. It just depends on what you want to do. But here's where the rubber meets the road. Our cost is going to go from here to here, which means we're going to have to spend $1.9 million more per year to run this, to achieve this service goal. And our revenue, let's assume that you're a salesperson, sales company. I threw $10 per call. That $10 is actually pretty important. But given, I might have 10 calls and I might make $100 per call, but only one of them sells. It means that my revenue is going to be $150,000 more, which means overall, in order to achieve that ASA goal, we're going to have to invest $1.72 million more into our business. Now, it depends on how driven you are by sales as opposed to service. This might be a perfectly great trade-off for you to have. 1.72 might be, we're a premium brand. We want people to be answered real quick. And that's great. But if we're a sales if we focus on sales, well, it's only going to net us another $150,000 a year, which means that this might not be the right thing. But other things that you could put in here are things like how often people have no wait time, or the wait time is less than 3 seconds, or how often, what is the worst wait time that you might have. That might be another column in your table. But you can do all of this with these kinds of simulation model runs to sort of lay out, here's all the things that are going to happen if we were to do this thing. And the question is, whether decision maker, what is it that you would like to do? Which is really cool. And this is just a sort of, like I said, a taste of what you can do with these kinds of models. Maybe next year if we do this webinar series, Sherry, I really want to do it. Next year if we do this webinar series, we can do some more things around what ifs and the kinds of what ifs that you can do, which would be kind of fun. Let me see if we have anything else here. Okay, models are important to get right. Validation is really important. If I were to run the wrong model there, you saw how off they were. That would mess up my analysis. I would be giving my decision maker the wrong alternatives to sort of decide between. But if you validate your model, if you prove that it's accurate, like we did, then what's going to happen is people are going to believe your analysis, you're going to believe your analysis, and the analysis is going to be more right. Models can be really fun. This is, for those of you who really like spreadsheet land, or fiddling with things. If you like to code, even you don't have to, but if you like it, this can be really, really fun because you start honing in on the things that are right for your particular business. Like I said, there's sometimes businesses are very different on weekends. That might not be your business, so that's probably not a good rule of thumb for you. But it might be. But you get to fiddle with it, and you can have fun. You can start seeing how accurate you are. You can show people your accuracy. When you show them your accuracy, they're going to believe you, which is really cool. And these what-ifs are endless. They're powerful. They get you noticed. I got my very first promotion by doing a what-if at Northwest Airlines way too many years. I think, Adam, you may not have been born then. But the thing is, everybody loves this stuff. Everybody, if you lay it out like we did, you can show, with these graphs, you can make CEOs believe your analysis, and you actually do a good job of laying out, here are all the alternatives for you. Every CEO loves a good what if, and like I said, you can get yourself a nice little promotion too. That's all I had here, and I'm going to turn it over to my buddy Adam again. So we got to thank you, and he's going to do a quick commercial break.
Quick commercial break. Yeah, I love seeing all of this stuff come together. So if you haven't checked out some of our previous webinars, I know Sherry hinted at them, please do so, because I feel like this kind of ties a bow on everything. We are, again, from Sharpen, and we like to say that we're the agent first contact center platform. And it's because everything we do is funneled through how do we create a better agent experience, whether that's through agent metrics, putting, all of your reporting and analytics into one place, having smart people like Rick to help you interpret your data. Our goal is to help, working in a contact center be frictionless. And you're seeing that throughout all of these different webinars. So thank you for those of you that have gotten a full bingo and you've been able to be a part of all of them. If you haven't, again, I would strongly encourage you to listen to some of those other ones because they do all feed into one another. So a lot of really great questions that have popped up, Rick. I think your brain is the best brain to answer them, but I think it's a good time to transition into the Q&A.
Great, and we do have a bunch of questions that have come in. Great job, Adam and Rick. And I also want to remind everybody that's in workforce management, performance management. Sharpen is one of the sponsors of a virtual conference taking place November 2nd, it starts, on workforce optimization. So if you have not yet registered for that, you may want to go ahead and register. Sharpen has a booth there, lots of content. They're also going to be doing live demos. So that's ecrmevents.com. And if you just forget that link, you can go right into the Serum Exchange page and and it'll bring you right over there. So let's go to our questions that came in. Let's see, we're seeing more and more about using AI to determine best modeling methodologies, as it can lock in different methodologies and applying the models that are most appropriate. Do you feel this is overcomplicating things?
Yeah, I don't think for this kind of problem, I don't think that this AI is necessary. Although we use a regret. Okay, let me take a step back. One of the things that's happening is, especially if you're doing this through a vendor, one of the things that's happening is a lot of vendors are calling virtually everything AI now. So things that used to be called statistics are now called AI. For example, I was talking about picking a weighting factor, and so we used a little regression model. Some companies will call that AI. So you sort of have to understand what type of AI they're talking about, whether it's AI or whether it's just the standard stuff that we've been doing. I did see a webinar from one of the big vendors who did 10 pages on AI, and then the next thing that they did was a bunch of Erlang stuff. And so, people are calling AI things that are not. So look into that part of it. Again, the most important part is to use the modeling technology or technique that is most appropriate for the business problem that you're solving. One of the problems with AI can be, so for example, we actually applied some AI stuff early on when we were, sort of dreaming up this webinar, and some of the results were actually pretty bad. It might have validated well on a chart, but the sensitivity charts were really disjointed and awful. And it was because it wasn't modeling a call center; it was modeling a curve fitting exercise. And that's not what you want to do. You want to model a call center. Now, the nice thing is with the Erlang A is that it is trying its best to behave like a queuing system, like a call center. So it's going to try its best. The answer, I guess, is make sure that you're picking the appropriate, quote, AI. I don't think you need it for this kind of exercise. As a matter of fact, I'm pretty sure you don't. But the thing that your vendor might be feeding you is an Erlang equation anyway, but they're calling it AI. So look into it a little bit.
So I have a question about AI, looking at it from a different, slightly different lens. A lot of companies are talking about a hybrid AI person and a person. So can you model for, an AI algorithm or model that's answering some questions and then the human agent answering for some questions?
Yeah, absolutely. That's a relatively easy thing to do. What you need is data on how many of the calls flip over to a human being. So if they're all being handled in the VRU or in the cloud computer up there, then great. If they're all being handled there, then you don't need it. There's no modeling necessary other than to know how many CPUs you're burning through and such, and how much data you're taking. But what you want to keep track of is at what point does that toggle to a human being? Maybe there are certain times of day when more of them hit your humans, and then we'll use the same exact sort of modeling that we do today. It's just that there is a process before it hits the human that we have to be cognizant of. Also, you might be able to dial it up or down based upon how busy your agents are, and so you'll want to make sure that your models take that into consideration or help you figure out when to do that best, if that makes sense.
Okay. Which model?
And I would add to that.
Oh, sure, go ahead.
Sorry, Sherry. Well, I would add to that the modeling becomes even more important as you get AI answering more questions, right? So to Rick's point, you're looking at the things that are getting through. But if your self-service is getting better and better and better, then the problems that your agents are dealing with might be getting harder and harder and harder as all the simple questions are gone, which can lead to changes in your metrics and a need to look at these models more frequently.
Right. And it also back to the performance management sort of thing, you might want to hone in on those things that the AI cannot answer and do a better job of training your agents just for that stuff. And maybe even then you'll make your AI better too.
Okay. There's a question on modeling and if there's better models to use for inbound versus outbound.
Oh, yeah. So your Erlang models are your typical, those are primarily for inbound sort of events. It could be chat, inbound email. It could be for phone, obviously. Outbound is a very different modeling process. And I don't think that there is a standard model, but here's the thing about it that's interesting, because I've worked in outbound shops before, is that when you're trying to figure out things like how do I schedule my outbound agents, the interesting thing is that your agents, they're not there to cover outbound. Instead, what they're there for is to make outbound. So I don't know if there's a distinction there, which is the work goes with the agent, not the work just doesn't happen. Meaning, if it's an inbound call, the call is coming in at this time and it's set. If I don't have any outbound, if I don't have any outbound agents at that time, well, then no call is actually being made. It goes with wherever the agent is. So the trick to doing that kind of analysis is to look at the relative efficiency in terms of contactability of your customers by time of day, and realize that if I put a lot of agents at this particular time of day, and it's not your customers aren't contactable at that moment, it means that they're not going to be very efficient. So, like for example, back in my day, I don't know if this is true anymore, but I was working in a collection shop, and we would do our scheduling, and we would understand that in the mornings is when they're most contactable. People are more contactable, and in the evenings. So you would build schedules around those times of day. But you can also keep track of, if I had one agent here at this time, based upon the handle time, based upon the contactability, here's how many more contacts I would actually make, how many more people would actually pick up. So you can do analysis around that, if that makes sense.
Okay, Adam, did you have something you wanted to add to that?
No, I'm just nodding a lot.
When providing information to your decision maker, do you find it best to show the end result and then backtrack to how you got there, or do you start with the method and then show the end result?
I think it depends upon the decision maker, right? Some people like to be, they want to sit down and understand exactly how you got there, and let's walk through it. There's a school of thought, which is you say that, these people don't have a lot of patience, so you just tell them the answer. It depends on the person who's answering it. I do like the idea of having a story, always telling a story, and as much as possible, although I didn't do it here, to turn things into stories if you can. So if you say, Bob from accounting said this, and I made him a bet about this, that whatever you tell him is going to stick, So if you can turn whatever, in terms of style, if you can turn anything into a story, it makes much more memorable.
Okay, stories always make things more memorable.
Yeah.
Right. Let's see. There's a question on the blended contact center, so inbound, outbound.
Yeah.
And the person that wrote in is struggling with occupancy for incoming and outgoing. So what's the best way to approach that?
Oh, that's a great question. That's a great question, and you may not be able to text back about it, but it depends on if you're on a power dialer versus you're on what's it called, preview dialing. That makes a difference. Question is whether you allocate outbound time as opposed to have it completely real world blended. A lot of companies will have you do outbound for an hour and then do inbound. So it sort of depends upon how you configured there. But your natural occupancy is from your inbound, and your outbound is again, if you're on a power dialer, then your outbound dialer is actually taking that. I think, I don't know the answer to this, but I think the idea would be is you could probably gather what your historic occupancy is when you're in that sort of scenario. So if I have a power dialer and inbound calls, I know how much time the agent is actually on a call or taking a call, and how much time they are idle, and you can actually derive it after the fact. And if I'm putting together a model, you can sort of assume that you're going to be as busy as if I have the same sorts of volumes and I'm running the same sorts of policies for outbound, that my occupancy would be somewhat similar, I think. Adam, you got any thoughts on that? Okay.
No, that was the way that my brain was working through that one as well as I was reading through the questions.
Okay. And Adam's been busy answering some of the questions.
Oh, I'm trying.
We've just completely run out of time. Any questions that Adam was not able to personally get back to you or that we did not get a chance to answer, we will forward those on to Rick and Adam. And I know they really love talking about this stuff. So they would be more than happy if you would email both of them or either one of them, and they will get back to you, and we'll also send your questions on that they can get back to you as well. In 30 seconds, Adam, most important thing to remember, 30 seconds.
I think most important thing to remember is that you can start on these pieces now. It doesn't require fancy software. I think Rick did a great job of laying out the foundation items. I'm going to use my last 15 seconds to say, Sherry's not kidding. Please reach out to us. We're both very geeky about this, and we will absolutely respond. So if you have a question, please reach out to us. We love talking about this stuff.
Rick?
I will echo what Adam said, is you can do it. You can do it. One of the problems with this math stuff is that it looks complicated. That's not on purpose, believe it or not. I think people do it to be exact, all this mathy stuff. But the more important thing is that usually the common sense is a big part of it. And a lot of things that people do are just commonsensical. It looks complicated, but it really, truly isn't. This whole ensemble thing, I bet you could buy a book on ensembles, and if I were to buy one, I wouldn't understand a damn thing that was in it. But all it is just taking averages of things. So it's super easy. Described in a complicated way.
Thank you. And this is the conclusion of the Sharpen series for this year. You can find all of the recordings on CRM Exchange, and you can see more of Sharpen at the virtual conference. At this point, we will be closing this webcast. Thank you, Adam and Rick. You did a great series for 2020, which was kind of an amazing year with all sorts of things going on, but it was a great series, and we will see you in a couple of weeks at the conference. Well, virtually, we will see you at the conference. And thank you to everyone that attended. And remember, you can always go back and see the previous sessions, lots of great information in those sessions as well. So thank you all. We will be closing this webcast. Have a wonderful rest of your day. Bye-bye.